We're now live, so I will introduce the session. Welcome. So the fifth session of the day is a discussion, and it will focus on redefining the upstream industry through IoT, AI, and edge devices. So it goes without saying, it's been a great day so far, and it's been very interactive. We've had lots of questions posed in the Q&A box. So great to have everyone here. I've spoken to many of these guys before, and I'm sure that you'll get lots of really good nuggets of information. So I'd like to welcome the following panelists. So firstly, we have Todd Anslinger, Center of Excellence Lead, Chevron Energy Technology Company. We have Fanindra Bolavaram, Remote Operations Manager, Global Production Operations for Apache Corporation. Hos Belyadi, Senior Data Engineer, Vine Oil and Gas. Lucas Green, Senior Staff Well Analyst, Maverick Natural Resources. And James Hughes, Edge Technology IT Product Owner for Chevron. So I'll be moderating the discussion personally, so I think we'll jump straight into it. Quick reminder though, so attendees have joined in listen-only mode, so you're all muted. Quick reminder about the Q&A box. Log your questions for me, for the panelists in the Q&A box. Can ask questions throughout. We'll either wind them into the conversation or pick them towards the back end of the session within the final 5 to 10 minutes. So let's start with each panelist introducing themselves. So we'll go in order as how I can see it on the screen. So if you could just provide a very quick overview, 1-2 minutes, who you are, what you do, and maybe some insights into your experience in the topic. And we'll start with Lucas.
Hi, thank you. My name is Lucas Green. I realized I haven't updated my LinkedIn in quite some time. So I'm actually the Automation and Operations Center Manager for Maverick Natural Resources. Currently, I'm overseeing the automation projects and spinning up some operation centers around the country for the company. We're going through a pretty heavy campaign of automating the company, especially given the recent events in the industry. So that's pretty much my background in it. Thanks, Mark.
Todd?
Yes, Todd Anslinger, IoT and Automation Specialist with Chevron in the Asset Performance Group. So I'm kind of leading the IoT strategy within Chevron since 2018 from a new sensor discovery standpoint and sharing the business value of some of these IoT solutions within Chevron. So I'm communicating with operations engineers and facilities engineers worldwide to kind of help accelerate the value gained by Chevron through these IoT solutions. So I've been working in the process control network, PLCs, HMIs, SCADA infrastructure for 25 plus years, and the last 4 years has been in IoT. So I'm trying to help the INC, instrumentation and controls engineers, know when to keep sensors in the PCN, when they can go IoT, and to understand the value of doing that. So real focus is being in the asset performance group is to choose those few highest value IoT solutions that we can scale across at least a business segment, upstream, midstream, downstream, or possibly across the entire enterprise.
Fantastic, thank you, Todd. Hos, over to you.
Yes, sir. Hello, everybody. My name is Hos Belyadi. I'm a data engineer, data scientist at Vine Energy. We just went public and changed our name. So quick background about myself. So my primary responsibilities are automating tasks that used to be manual in the past. That's number one. Number two has been, I've been working on, getting the data. We have a lot of data from completions and reservoir and drilling, getting all that data in one central data warehouse where we can utilize. And once that data is in one central data warehouse, that's what we can leverage analytics to visualize it using Spotfire and Power BI. And then number three is using that data and applying different types of machine learning algorithms to find hidden patterns from that data. So these are my three main responsibilities. So automating tasks, getting all that data in one central place, and also using AI and machine learning to find hidden patterns within the data.
Fantastic. Thank you, Hoss. Fanindra?
Hi, everyone. That's Fanindra Balavuram. People just call me PB by short. I work for Apache Corporation. I run their remote operations center and responsible for digital operations. I've been in the industry for 20 years, engineer background, but I've done lots of roles in operations. I used to work for BP for 17 years. The last few years, I was responsible for the digital transformation. You probably heard that was in 2015 when the prices crashed in the industry, and we had to figure out an alternate way of running our operations, much more efficient and productive. So I led that transformation for 2 years, and then after that, I joined Apache, and I've been working with Apache operations teams on digitizing, as you said, all the stuff that you guys are talking about is what I work with the teams. I'm not exactly an SME on automation like you guys are. I am the actual recipient of the information. So how do I help the guys in the field? And how do I make our lives better for the guys in the field? How do we enhance safety, environmental performance, reputation, and then bottom line, production and cost goals. Thanks.
Fantastic. Thank you. And Jason, over to you.
Yeah, thanks, Mark. My name is Jason Hughes. I've been with Chevron for a little over 15 years now. I've always worked in the upstream side of the house. So I started off in geophysical, geological, and G&G. We'll just say G&G. High performance computing space. So on seismic processing clusters and things like that. And naturally, I wanted to get closer to the bit, as we say, and learn more about the business. So ultimately, that led me into supporting our deep water operations, and then that eventually led me into edge technology. So I've moved into this space in the last 5 or 6 years. So my role now is edge technology operations product owner. So my job is to kind of bridge the gap between the business and the technology. My team travels the world and enables communication and quality of life, as PB said, at the rigs. So our edge technology solutions not only help us gather high quality data from our rigs, but it also enables base business technology at the rigs. So yeah, happy to be here.
Fantastic. Well, certainly seems like there's a great deal of experience there. So perhaps we'll jump into it then. Let's maybe set the scene. And I think, Lucas, you said this in your intro, alluded to the past sort of 12 months and what's happened. So obviously we've had a global pandemic, which clearly had quite a lot of impacts at the start, but also, perhaps going further, what would you say was the number one challenge at the start of the pandemic versus what the challenge is now? And how have things changed over that sort of period?
Sure.
And perhaps we'll start with Lucas.
Okay. Well, for us in particular, we've always been very automation driven. I guess a little bit of background on the company. So I was brought into the company maybe well over 2 years ago, specifically to automate the company and start operation centers and kind of have a centralized hub where we're controlling most things, most all the interaction or wellheads from a centralized location, through automation, really, reduce the need for human intervention in a lot of places. So whenever the pandemic hit us, I guess you could say we were poised to do well in it, but we had definitely not taken the operations and the SOPs and the automation we had put in place and taken it to that level of an extreme yet. To where we weren't sure if we were going to be able to have people out there or even in the office, taking all these operation centers and basically making them remote and putting them in people's bedrooms. And so we fared very well through it just because we were prepared in a lot of ways, at least on the operational side. Of course, on the corporate side, I'm sure we dealt with the same thing that everybody's still dealing with. Remote work and all that stuff. But as far as our field operations, we were fairly well poised. And just from that experience, we've been able to really refine how we go about it. We've been really fortunate to be able to stress test everything that we put in place, find our weak points, find our vulnerabilities, and fill those, and really refine our designs. That was probably our number one challenge as far as going into the pandemic. Now coming out of it, we really have a different scope of work that we see in our automation. It's driven a lot of process automation decisions that we've made. A lot of the field automation, as far as the hardware goes, I don't want to say there's a set number of options because you can get as creative as you want, but there's a pretty finite box of things that you like to do within certain economic windows. And we have those pretty well defined, but I would say on the operational side, the process automation and really stress testing our equipment has been what we've come out of the other side of it with.
Thank you. And perhaps we'll ask Hoss.
Yeah. So before the pandemic, I would say we had a lot of processes that were not automated, and it took a while to get that process automated, and especially on the field production side. Now coming out of the pandemic, I think we've done a great job enabling a lot of these edge devices on our production side to automate a lot of the tasks that used to be manual. So I'll give you a simple example. For example, we have a lot of intermittent wells where we have to go on site and change the set points of these intermittent wells to optimize the gas production rate. That process used to be very manual. We would change it and then subjectively and empirically look at the data to see if it's looking better or not, and then change it accordingly. Now, we're moving into a process where all of that information is, being done automatically through an edge device. We have optimization algorithms written on these edge devices that control the well, when to open, when to close the wells. So before we went on the pandemic, we had, a lot of manual stuff going on. Now, after the pandemic, we're coming out of it stronger because we've found some sticking points that really held us back and took a lot of time away from our production guys' man hours, and we're kind of automating that freed up a lot of time for those guys to focus on more important stuff as opposed to manual unloading and changing the set points on these wells.
Okay, thank you. And what about, perhaps we'll move to Todd.
Yeah, so what this has done is it's really accelerated the want or the need for especially IoT solutions, and that was good, except now if it's involved installing something in the field, okay, well that was kind of hampered last year based on travel restrictions, or even fewer people at a downstream location, let's say, or even upstream location. They didn't have time to do that because they were trying to cover a bunch of other things. So so what that's done is, in the past year, it's kind of changed our designs, because in this year there's been a lot of innovation going on. So there's new sensors that are available that may fit, let's say, existing infrastructure that we have. So it's kind of changed our solution from the point of a year and a half ago. So now there's a lot of innovation going on, and there's a lot of solutions. So being from an asset performance group standpoint, it's harder to choose, those few that have the highest value, because there's a lot more to choose from now. So, which means it's taken a lot more coordination with business units around the world too, to find out what they're actually doing and what they're seeing success in. So it's accelerated quite a bit from an IoT standpoint.
Okay, and PB?
I agree with all the panelists, what they have said. With our portfolio, we have highly automated operations and ones which are much more legacy, where we don't have any automation. I think Hoss talked about that, intermittent wells, and it's not economical. So that's one thing we had to remember last year was the pandemic. It did I think approximately 23 weeks ago, last year at this time, we had the negative oil prices. And that really shakes your market up. So the first and foremost thing is to make sure that we know exactly where the data is. And that took two to 3 years prior to this pandemic. So we had to prepare. We didn't think it was going to be a pandemic. But when we talk about anything to do with AI, ML, and stuff, it starts from foundational stuff. It is around data. Let's make sure our data architecture is right. And then all cool things can be done later. So when we did that piece, and we invested quite a bit of time, thanks to our IT teams who really put in a lot of effort into it. Once we had that architecture, we were ready to actually pull the trigger. So that again brings the cultural aspect of it, which is basically how adapt and how elastic are you to move very quickly. When it goes to negative prices, are we ready to understand what we need to do to legacy assets and what we can do for or highly automated assets? Where do we keep them online? Where do we shut it down? The bottom line is, for me, there is boots on the ground are required. I mean, I think you can use automation, but when you come down to it, repairs and maintenance, and if you want to go take a look at it, with comms towers going down, you got to have people down there. So that was very essential to maintain business continuity. So that was a very big challenge for us, and making sure that we have people available. As I think Todd was saying, it wasn't an easy market to find people. So being very clear from a business perspective as to which ones you want to keep online, which ones are not economical, you've got to have that first in place. Once we have that, that was a big challenge actually, but we came over that really well in Apache. Kudos to a highly integrated team. That's another thing, that we were all working remotely, and yet collaboration was possible. Something that accelerated. I think Todd was talking about some of the things that we will talk about later on. This is one of the examples around acceleration. The challenge right now is basically it hasn't changed, right? I mean, we can go through another low. This was a virus, and next time it could be something else, right? It's a geopolitical. So we got to be ready for that. There's also a challenge from an external perspective is, whether it's ESG goals, our competition with other industries in terms of return to shareholders. How do we make sure that we can see the stock price going up, and then adjusting the new normalcy? It's not going to be the same as what it was before. There are changes, and those are the things that will be interesting to maneuver as we move forward. I think Haas said about business policies. Yep, we've learned how to utilize working remotely. Now we're going to come back again. Are we going to bring in the bad habits again, or are we going to adopt to the new ones and say, yeah, let's take it to the next level, right? That's the integration piece. So those are a few things from an operations perspective.
Thank you very much. And do you have anything to add, Jason?
Sure. Again, I am on the operations side, so like PB and Todd said, I think we had at least felt a pretty good momentum prior to the downturn. We had started to get a lot of buy-in from our business units and funding for our edge technologies, which is really, we try to sell it as a platform in order to enable digital initiatives. So whether it's just getting the data or doing something emerging, right? We have to have that kind of base communications platform there. So we had gotten a lot of momentum in that space, and as we had to ebb and flow with the markets, we saw a lot of people pull back, or we had to shut down rigs. And then we had to deal with things like, a lot of what I do is on the physical hardware side. So storage of the equipment, where does it go? Asset lifecycle management of those devices as they're off the network became a real pain. And then, of course, now things are starting to liven back up some, and we're trying to figure out, what can we get back quickly, right? So it's really taught us how to be more efficient in working with our devices at the edge and getting things on and off the network quickly. So we really stick to a factory model and try to have a repeatable process, and we also leverage boots on the ground resources like PB was referring to, that really are key to keeping our operations alive. So I think we've learned a lot about how to quickly deploy these assets in the field and how to maybe simplify them a bit, because I think we were building very complex solutions previously, and now we're trying to kind of simplify them into a smaller form factor, different power approaches and things like that, where we can get them, just make it more flexible platform to, for us to quickly deploy and get it in the field. So
Okay.
I think we've had some good lessons learned.
All right. Well, appreciate it was quite a broad question, but I think it's important given circumstances and where we've been over the last 12 months to kind of set the scene and just to explain a little bit more about the sort of challenges that you guys have faced. But perhaps, looking a little bit more specifically, and ultimately this event's is about automation and technology, right? So perhaps now that you've shared some of the challenges, what about some of the solutions? So looking at the innovations that have occurred over the last sort of 12 months or so, and supporting technology, what sort of things have you applied to solve some of these challenges? And have you seen certain strategies accelerate? And I won't pick on anybody in particular. Who would like to go first on this question? Todd, over to you.
So what this has done is we have a normally unmanned facilities group. So thinking about designing facilities to be unmanned, so that's taken one piece. Of course, that's longer down the road until we see value from that. But one of the highest value IoT solutions that we've done is in monitoring brownfield wells, and I mean wells that have no SCADA on them, that's been since like the 1960s when they were put online. So what we did, and again, this is going to feed into exactly what Jason was talking about, because we started this a few years back. We hardwired pressure transmitters into a cellular gateway, which had to be in a panel. Okay, and that's what that did for us is out of all the wells, instead of the person at the inlet separator saying, hey, our flow rate's down, we got wells down somewhere, go look for some, putting pressure transmitters on a well that, let's say, is logged off, and it notifies and says, hey, you got a low pressure here, meaning the well's down. It tells them exactly where to go. So it doesn't take a week or two to get a well back online. So we're saving in lost production. Okay, so I mentioned we hardwired typical transmitters to a cellular gateway. Well, now with newer technology, with sensors that can fit right on the MPT fitting that are, let's say, LoRaWAN, NB-IoT, Cat-M1, that are now Class 1 Div 2, which they weren't, 2 years ago. Now we're kind of simplifying, to Jason's point, and making it easier to install where we had someone that had to go out that could mount a panel. Now an operator just screws it on, pushes the button, and walks away, and that's part of the cost, right? The installation costs are a big part of that solution. So with technology advancements and making it easier for the operator, we don't have to pay someone, $2,000 to go install a $200 device. We just have the operator do it.
Okay. PB, you're nodding there, so perhaps we'll move to you next.
I'll take it. I think I agree to what you're saying. It really helped in terms of multidisciplined, multi-skill talent because the technology is available now. I don't know if it is common in every industry yet, but I think that's something that we have to adapt. So I think we are in a journey on that one. For me, I think adoption, because when we get a shock like this, we realize that we had to work differently. So when we talk about a cultural perspective, it was a lot of, I'm sure all of us have been in this place. I think Lucas probably can speak to this about too, is, operation control centers, and, there's a whole thing around whether the operators in the field are losing control, right? Losing jobs and stuff like that. So that goes with upskilling talents that you talked about, right? Which I completely agree. And then what this pandemic did was we had fewer people, people getting sick. You have social distancing. You had to quarantine. That's when the case for accelerating remote operation centers became very powerful, because you have to still operate, and we have to watch the wells. Control is one thing, but at least monitoring and surveillance is the first step. If we can do that, I think, Todd, you mentioned, hey, there's a pressure transmitter out there. I've seen something there. I'll check it from an operating center and see if I can diagnose it, and then say, yep, and then send the people where they're supposed to go, because we only have that many people. So that was an adoption of hey, the process flow coming together, right? And and it happened because we tried through push. It will not work. We knew it will fail. We've tried for a number of years, and here is where adversity brings the best in everybody, and everybody adopted very quickly. At least in our company, we did, and it became a pull. And now we actually have gone through the pandemic. We have worked different ways, and now we are actually seeing more and more use cases that you talked about, Todd, before. We are getting it from the field. They're saying, "Hey, I need help with this. Can you find a solution?" Okay, it may be an equipment solution. I think Haas talked about here is my painful thing on a paper process. Can you make this an easy, like a mobile app or something that actually I can do and effectively work, right? So those are the things that I've seen as some examples of how we became innovative in our way of working, and accelerated how we actually have come through really well over the last 12 months. I mean, there's no other industry that has done this, frankly, and the way we reacted, especially given the challenges that we had to keep the lights on and provide energy to the world.
How about you, Haas?
Sure. Yeah, I'd like to add to what Todd and PB have mentioned so far. So I'm gonna, go back and talk about a little about drilling, then go to completions, and then go to production. Okay. So on the drilling side, we all know, I think a lot of companies are, getting that data, that real-time data is important, but at some point they're like, okay, what can we do to make real-time decisions, right? And that's the key to taking this edge device game to the next level, right? So on the drilling side, for example, as we get this drilling information, we get weight on bit and differential pressure and pump rate and all that information, right? What can I do to optimize these parameters real time, okay, and basically make real time decisions on site to improve with the objective function of maximizing rate of penetration, okay? So that's one of the projects that we're still working on. I think it takes a little bit more time. It's not as easy as, okay, let's just optimize the ROP. I think everybody would love to do that, but I think the goal here is to use these edge devices and deploy machine learning models at the edge and make real-time decisions and change variables real time to optimize, for example, on the drilling side, rate of penetration. That's one example that we're working on. We haven't done it yet. We're still working on finding the best solution because there are a lot of complexities with the formation. We're actually in Haynesville. There are a lot of complexities that comes with that, But I think the true value comes in. There is a lot of value in getting that data. There's a lot of value in understanding all the parameters on the drilling side and everything else. But the true value comes in when we can make real-time decisions to change these variables real time to maximize the objective function of maximizing the ROP in this case. Now I'm going to move to the completion side, right? So on the completion side, one of the challenges that I think everybody has is chemicals. We pump different types of chemicals, friction reducer, and some, depending on how hard a stage treats, we might pump linear gel or cross-link gel, right? So on the completion side, these decisions are made by a consultant who is usually experienced, at least 10 plus years experience, in the field. But if you look at the behavior, so what we've done here at Vine, we've looked at the behavior of each consultant that we have. You can call me a spy, but but you can look at, let's just say we have 5 consultants across one frac crew, and these consultants, if you look at them, you can actually observe that this consultant pumps more FR and more gel compared to the other consultant, right? Now, what is happening here? What's causing that? You might say, well, the stage treated harder. Sure, you might have a higher amount of FR and gel on one stage. But on average, if that consultant has pumped like 30, 40 stages, and the other consultant pumped like 30, 40 stages, on average, why is consultant A is pumping so much more chemicals than consultant B? Now, what can we do to leverage, edge devices and IoT to minimize the amount of chemical that we pump? What can we do to provide a recommendation system for these guys? Hey, consultant A, you might be running a little bit high on the FR. We recommend dropping it down, or we recommend changing this parameter and that parameter to minimize the frac stage cost. And this can be done again with coupling machine learning model and edge device, and applying that real time to make real time decision. That's an example on the completions that, as I said, we're still working on it. It's like, so far we've just analyzed what's happening and what can we do, what we can do to minimize the cost. But we're still working on, minimizing the frac stage cost for different wells that we do, which adds up to be millions of dollars. I mean, we're not talking about, the amount of chemicals that we spend on a stage level, just minimizing that by 10, 20%, or let's just say 5 or 10%, could easily, depending on how many wells you drill, like a year if you're Chevron, Todd is smiling, because, like for these guys, it's like, we're talking about tens of, probably hundreds of millions of dollars, but for like Vine Energy, we don't like drill as many wells as Chevron, but still it is significant, we still drill a lot of wells in Haynesville, and both Haynesville and Mid-Bossier, so it is still pretty significant. Now, this is the drilling side, right? Now, production side, I think I gave an example on the intermittent optimization. Same thing can be applied to plunger lifts. If you guys do a lot of plunger lifts on your gas wells, you can also couple these edge devices and machine learning models to make real-time decisions to free up time, And another advantage of these, I think, edge devices that a lot of people probably are missing is reduction in ESG, reduction in methane emissions. Like we've seen that, we've applied this intermittent optimization on the production side, and we've seen a significant reduction in methane emissions just because we're not manually unloading these wells anymore. We're letting the machine learning model to optimize these wells automatically for us, and as a result, we have to do a less number of manual unloads, which leads to a significant reduction in methane emissions. So a lot of positives that comes out of this. Some projects, like we've been working on this intermittent optimization for the past, I would say, 6 months now. It takes time to prove the concept. It takes time to show the value of it. But once the concept is proven, once the value is shown, then scaling it would be pretty important. And I think at that point, then we have to talk about the installation cost. What can we do to reduce the amount of money that we spend on installation? And because it does cost a lot of money to install, and also maintaining those edge devices over time. What can we do to minimize maintenance on these edge devices to also minimize the number of man hours that we spend in the field, and sending a guy to the field to change out these devices, or to if they cannot remotely reconnect the edge device, for example, to the SCADA, what can they do? What can we do to send the guy to the field to do that? So these are the 3 main examples that I wanted to talk about. So the big picture that I want to talk about is just what can we do to use these edge devices to make real time decisions, and create value real time, as opposed to analyzing the data afterward. I'm not saying there's no value in analyzing the data afterward. There's a ton of value in that, but I think the goal is to just be able to make decisions real time going forward.
Thank you. Very, very detailed response there. Lucas or Jason, do you have anything you'd like to expand on that?
I'll just piggyback a real quick comment on that, particularly around the operation centers. So one thing that we've done, and PB touched on it, but is really focused where all of our data is going into one place, and then kind of Haas had mentioned we're in the middle of a few different pilots for our artificial lift optimization. Just that goes along with pattern recognition, machine learning, to really optimize the production with, I guess, cutting headcount isn't necessarily the right way to put it, but with less resources available to you, especially in this recent scenario we've been through. It's one thing to bring everything in and start monitoring it, and then the next step that you'd want to do is get control, and then after you get control, actually optimize that production. And if you can do that with a lot less manual entry or human error involved in that scenario, you'll be quite a bit ahead. So that's one area that we've really been focused on here. So you mentioned plunger lift, which is a really tricky one, especially if you're using your SCADA data and your pattern recognition and all that stuff. Data quality becomes extremely important in those scenarios. Rod pump, I think a lot of people have figured out at this point in that scenario. And so I guess the areas that we've really started honed in on, kind of putting rod pump to the side there is GAPL applications and rod pump and plunger lift applications. So we're really excited to see what will happen over the next, or at least I am personally, over the next 6 months, a year, just to see around the industry what people do in those spaces, because it seems like a lot of people are trying to attack that right now, and I think it's got a lot of promise to it. So.
Thank you. Jason, do you have anything else you'd like to add on that?
No, there's a lot of good information there. I think one interesting thing that's happened with us around all of this is, Chevron not only went through the downturn and everything, we also did a company-wide reorganization. And I think one of the things that I noticed was that we had been doing a lot of this stuff in silos, like within each individual business unit. It was actually interesting. I saw a job posting internal for Chevron Shipping that actually took my job posting from my group and just kind of stole it and copied it. And what that made me realize was that we're doing the same thing in two different places. So I think one of the things that we've seen that we're still learning and growing from is we're managing a lot of this from our central our central team, right? And so we're trying to find efficiencies in some of that. So we're not deploying conflicting solutions or, to Lucas's point around data quality, right? Data standardization is important. Are we using the same data lakes, and the data formats as we go across upstream, downstream, midstream, areas? So we've been doing a lot of work in that space, and it continues. So the more we can standardize, not only within us but across the industry, that seems to be helping a lot.
Fantastic. Well, we've heard the term culture and workforce mentioned quite a bit. Obviously, very, very important. But I mean, the pandemic's obviously shifted things, and you've had to transform the workforce and change things quite rapidly as well. So perhaps maybe we can talk a little bit around that. How has the pandemic changed things from a workforce perspective? How has it influenced new technology, and what have been the sort of cultural strategies that you've had to put in place to change things? Because obviously, when the pandemic struck, things had to happen quickly, and culture's obviously critical. But when you have to maybe change the mindset and culture of an organisation, big organisations at a rapid pace, what kind of impacts does that have? So there's probably about 6 or 7 questions wound into that one there. But who would like to go first on that?
Maybe I'll go with as you said, big organizations. I'll talk about smaller organizations. So we have our challenges too. In small organizations, we are very quick to adopt and make changes. We are I don't want to use the word agile, but elastic. We are quick to we decide and we execute it. Okay, that's good. At the same time, what happens with that is we do not have. We run into the other side of the. Every strength also has its weakness, right? So the other weakness there comes in is that it is not integrated. So we will not be pulling together or rowing together, right? We'll be rowing fast. Everybody's rowing fast, but it's not in the same direction, and we can't build the value. So that is the piece that we had to get right in this pandemic. And that's where a lot of cultural change, being very specific, because it forced us into to think very carefully where we invest our dollars, because there was only so many dollars are available at the time. Resources are limited, so we had to put them in the right place. So for a small organization, for us like that, we had to be very specific about our goals and very, very clear, and then make sure that we give, talking about technology, giving the space for the guys in the field to go and execute it, but being very clear about what we want to execute and why we are executing. It's very important to talk about as leaders.
And then from our standpoint, I do a lot of technology training with IoT. Switching from being in person and being, engaged for a day or whatever, switching to do that remotely or virtually, that was kind of a challenge. I prefer the getting your hand, shaking hands and talking with people. So from the training standpoint, that was a little tougher to manage. From a support standpoint, thankfully we had HoloLenses put everywhere in Chevron to where, instead of Nigeria call and say, hey, we have got a problem, will you come over here? Well, it takes, a week to get over there and go out and fix things. Well, they had a HoloLens, so you just get on a remote expert call and you were fixing things within a matter of, minutes or hours instead of weeks. So that was a big culture change. And so it kind of forced some of them who maybe didn't use technology as much to do that. And then once they saw the value of using, in this case, a connected worker HoloLens, we use it a lot more often now. So, and even going to the construction side of it, FATs that would require us to fly to wherever they're building a platform, they maybe just flew a HoloLens there, and we did the FAT, from the guy sitting in his house and another person on location using a HoloLens to go around and do the FAT. So it really changed a lot about how we did that. But now that's worked into it, and I'm sure we're going to see some of those gains stay because we're not traveling as much, whereas we did before.
Yeah, I'll say another thing that the edge technology has enabled for us is we deployed a Class 1 Div 2 camera solution at some of our rigs for looking at the shale shakers, and while ultimately we didn't kind of go forward with it due to a couple of hardware issues and just installation problems and things, but I think the pandemic also showed us that we can use that technology for many things, including remotely looking at those instead of having a mud logger go by and inspect them. So I think that's one thing that I kind of alluded to early on, was that I'm hoping that these kind of examples will help us reinforce the need to have that technology. I like to use the term platform. I don't know if that's really correct, but we have to have that base at these locations so we can not only get data, so we can do automation, so we can do, and enable all of these other digital initiatives. But without the kind of the edge infrastructure and the communication towers and the equipment that we need and the boots on the ground to keep it, working, it makes it difficult to do these things. So I think the more that we can talk to our business partners and help them understand that we need to have those things there and not just focus on just the sensor, right? And they think it just goes sensor to cloud. Like there's things in between that have to happen. So I think that's one of the things that I spend a lot of time talking to our business about is, hey, yeah, we can do it, or we can even pay a third party to do it for us. But we prefer to kind of have our own solution at the rig sites to help enable not just the data, but all of these other initiatives that we're working towards.
Fantastic. Would anybody else like to expand on that?
Yeah, I can talk about a little bit of report automation. So one of the things that we've done here, like internally, like with the pandemic, like we used to have guys that spend so much time preparing slides and preparing different types of reports, manually, and now that we have a lot of the data that we have comes into a central warehouse and everything has been very much automated and streamlined. We can create automated emails that can be sent out so many times a week or so many times a day that provides the same exact information as opposed to guys spending half hour every morning, creating those reports, and I think like at first there's hesitancy about the quality of the data. There's always, oh my God, I don't trust this number of stages per day. I don't trust this number. And then once you show them that this is the same exact data coming from same source that they were pulling from, except it's just automated. They don't have to go in and pull that information every morning. I think that has really created a lot of streamlining within the organization, and those guys can spend their time on more important stuff. Like for example, the operations guys can focus on operations, as opposed to pulling data manually from different sources. So I think that has really helped us, like internally with automating a lot of these reports and sending an automated email, and it has been pretty much a game changer for us here at Vine.
Lucas, would you like to add anything, or?
Sure, real quick. Jason mentioned the infrastructure and having that in place to build on, and that's presented a really interesting challenge for I think for a lot of people, but myself for sure. In terms of we've got a lot of automated assets, but we also have a lot of stuff like that Todd mentioned was back. I mean, we have stuff that was back from the 40s. And it still leaks out a few barrels a day. But how do you go about automating that? And then if you don't have the infrastructure in place, how do you really go about automating that? If you would even have to stand up an infrastructure to support that automation. And so that's presented a really interesting challenge where Haas has mentioned edge computing several times. If you can put something out there to where you don't necessarily have to be able to see it in a SCADA system, but it's a smart enough device where it can make operational decisions for you. That's a pretty powerful piece of equipment that we've really been interested in developing, or partnering with third parties that are working on that kind of stuff. But I mean, just with the kind of the shift. I mean, you mentioned culture, kind of a shift in mindset from, hey, we've got lots of people, we've got everybody running around doing stuff all the time. Well, whether it's artificial or kind of driven from outside forces like it has been recently, or organic, just because the industry is always getting more efficient, having to compete with other people in the industry, the energy space. It's really driving us to come up with those solutions. So I see a lot of value there in at present, and then obviously coming out in the future. Because I mean, these things still are economic as long as you find a way to pump them economically, right? So yeah, that's all I've got. Thank you, Mark.
Okay, so we're into the final 10, 11 minutes. We do have a couple of questions from the audience, but before we go on to those, I just had a quick question around security. So obviously we've talked a lot about new technology and how things have changed, but how has that impacted the way that information is protected and the security strategy that's around it? I don't know who would like to go first, but I can pick on somebody. Lucas, perhaps we'll go back to you.
Sure. Yeah, and mine will be short and sweet. Our strategy is fairly simple. Obviously, there's going to be lots of layers in place that from the corporate IT infrastructure side. But just speaking, I'll just speak to the operational and SCADA side. We've completely separated our corporate networks from our SCADA networks, to where throughout the country, all of our SCADA networks are on their own domain. They have no way to speak directly to our corporate network, which I think is becoming more standard in the industry. And really that's just because we don't really foresee a way that we can protect against everything, right? So if you just literally lock that down and really try to put a ton of emphasis on your perimeter control, where, a lot of this equipment out in the field is decades old, whether it's a pump-off controller from the 80s or the 90s, or, an old Bristol controller from the, late 80s from Chesapeake, something along those lines. Like, a lot of this stuff is not safe in a technology perspective, right? Like, it has no security built into it, and it would be completely uneconomic to go and rip and replace all that stuff. Like, it could just pretty much never happen. So really what we focus on is a lot of perimeter control, who has access to the SCADA network in general, and then just having a couple layers built into them, and then really separating that from our corporate network, so that, the corporate infrastructure that is often attacked has no way that they can jump that and get operational control of a piece of machinery out in the field, something along those lines. So,
what about from your side, Todd?
Yeah, what Lucas mentioned, obviously there's varying levels of scrutiny. If you're in the process control network, that's scrutinized the most and has to be the most secure. Business network, even the same thing. There's some IoT things that we were going to have come into the level 4 business network, but access to the Chevron, if you get hacked, access to the Chevron network is access to the Chevron network. So that's why it's important for our engineers to understand, okay, what needs to go in the process control network, something with closed loop process control. Something that doesn't have that can be strictly IoT and go straight to the cloud, and then that reduces your risk. Because if someone hacks that stream, okay, they're getting a tank level or a pressure. They can't go back down to that pressure transmitter and do anything that's going to affect our control system, because that transmitter is not tied to the control system. So that's where Lucas is talking about that separation. That's important for us to understand because of a risk standpoint, but the bigger thing from my business value preaching, so to speak, is the cost standpoint. If you're going straight from the sensor to the cloud and that's where you're going to do your analytics, that's one hop to get there, versus going to the process control network. Yeah, you can still get to the cloud, but it takes 8 different steps, and you have a whole host of security checkboxes you have to tick, 100 versus, let's say 20. So it's a big deal.
PB?
I think I completely agree with what Lucas and Todd said, and it's pretty much, just in interest of time, there's some Q&A questions, so I completely agree with what we both said. Absolutely.
Perfect. So I think should we move on to the audience questions? We do have a couple in here, so I will read them out, and I won't pick on anybody in particular. So just let me know who wants to address them. But the first question is, how have IoT devices reduced downtime or spare part inventory? And could you speak to any challenges that remain?
Sure, I can speak to a quick example. And I don't know how much it qualifies as IoT as much as data science, but we talked about predictive analytics a little bit. We've got it set up on a lot of our compression, which I'm sure this is becoming more and more standard across the industry, but where you're monitoring everything on the compressor, right? Your cylinder temperatures, your stage pressures, your discharge suction, all that kind of stuff. But in that rotating equipment, that's a really high value place to have that kind of investment in your automation, because you can start to get warnings before things break, and so before something catastrophic happens to that piece of equipment, you're sending alerts to the right people at the right time. That's a nice quick example of it where we found value in it.
Yeah, and then building onto that, we've tested vibration transmitters that, we only report once or twice a day, but it also reported a temperature, and it found a temperature on an H pump going up because the seal was going bad. So gave us time to get up there and take scheduled downtime to do that, and then the well monitoring is another situation, it's putting it on, and someone nailed it. Okay, it still ekes out a few barrels a day. It wasn't economical to put a $20,000 or $30,000 SCADA solution on a well just to get information back. You had to add infrastructure, like Lucas was talking about. But something you could take $1,000 or $2,000 to put a couple of pressure transmitters, and it uses cellular, which is an existing infrastructure. Then you can, like I mentioned before, we're saving lost production by knowing exactly when the well goes down and which well it is, and going and getting back online. Now that's one of the things. Anything that we figure into the cost or the benefit associated with the solution, it's the biggest piece is around the production that we can, not go down, saving on lost production.
I heard something recently or it was a little while back, but I thought it was pretty cool and interesting around spare part discussions and where this automation and IoT sensors can potentially, where it may be going. And I thought it was super cool, so I'll share it. But the idea of, like Todd was talking about, we've now identified that a pump is beginning to fail, and its seal or bearings are going out, and so it's less efficient. So right now we keep spare pumps at the rig, or parts or impellers or whatever it might be, and there's this notion of eventually we may be able to 3D print parts, and so we can even automate that whole stream of, okay, this part is starting to fail. Instead of shipping it out from a manufacturer, we just license that part from them, and we can 3D print it on site. There's some crazy things that we're going to be able to do in the future that I think are just super cool.
Perfect. So I think we've got 3 minutes left. So perhaps we'll ask one more question. So this is a question that was asked quite early on, actually. So PB and Todd touched on the difficulties of selecting priorities for projects. PB mentioned the increase in requests for help in the form of use cases. Is demand from the stakeholders the best or only practical way to set those priorities? Not sure who.
Oh, demand from the stakeholders is the best. No. So it has to be both ways, right? I think that's a key part. But when you go through a shock like that, you have to look at business outcomes, right? First and foremost thing. There are some cool things that stakeholders want to do, but we probably don't have the time for doing it because we were reacting very quickly. So it depends on what timeline you are on and what's happening in that environment. That's elasticity that I was talking about. And in an elastic kind of an environment, it's very difficult to go systematically, I'm going to go this. I'll get a group of people together and we'll make a decision. And it ain't going to happen. When you go through a heart, we basically went through a heart stroke, right? So first thing you want to do is make sure you can survive. Then you can do, once you're surviving, then you can get back on the treadmill. Then you can do all kinds of things and improve your performance. So generally speaking, in a normal environment, I would say, yes, you want to get your stakeholders engaged. You want to get your use cases and then value them based on, what is the value and what is the effort required for executing it. So I've always run that all the time, value and effort, because it's a integrated thing. The value comes from the business, the corporation, from operations outcomes, and the effort required comes from the IT. They have to build the solutions for us, right? So it has to be a combined conversation.
Yeah, and I agree. It's based on business value, and where you have some business units may not agree with the business value, the effort that PB was talking about, that figures into the cost of the solution, right? So whether it's a contractor installing something in the field or what, but so it's kind of getting agreement around, okay, we're going to focus on business value. And we use a lot of business improvement networks, we call them BINs, and asset classes that help to establish those priorities. But again, it all focuses on business value creation.
Okay, so we're dead on time. So I think we'll conclude the session there. So thank you very much to everyone. Thanks to Lucas, Todd, Jason, BB, and Hoss. Really appreciate you taking the time to share the insights. I think it's been a great discussion, certainly very insightful, and the questions that are coming from the audience shows the engagement. So really appreciate it, and I hope to see you all again in the future, and hopefully next time maybe we'll be meeting in person.